Hello, math students. Welcome back to our module on linear equations. This is lesson 27 called Nature of Solutions of a System of Linear Equations. The goal for today we will use A1 divided by A equals B1 divided by B and C1 divided by C to determine the solution. So honestly, we are working with equations that are written in standard form, and we are comparing their constant coefficient amounts that are attached. The question that I want you to be thinking about in this lesson is, what is the only type of solution left? Okay, so in the last couple of lessons, we have been talking about the possibility of there being different types of solutions based on a system. And when you have different slopes and different y-intercepts, you are getting a intersection or point of intersection between the two linear equations in the system. And so that tells you that there is exactly one solution. Then the next lesson we talked about, well, what happens if they never intersect or they never collide? Well, we discovered that if they never intersect or they never collide, it's because their slopes are the same, but their intersections, their y-intercepts or their intersections of the y-axis are different. So there has to be one more. And the reason why I'm saying there has to be one more is that you've learned earlier on in this year that when you're working with coordinates, that sometimes you get no solution, sometimes you get infinitely many, and sometimes you get exactly one solution. Well, this applies to systems of equations the same way. And so today we're going to look into that. All right, things to know. What is the solution? So in our previous lesson, we learned how to take care of this. And what we need to do is we would like to this time use this to help us figure things out. So right now this line is written in slope-intercept form. So what I want to do is I want to turn it back into standard form. So in order to do that, I would take the x value and to unhook it, I'm going to subtract it off. So now I have negative 1/2 x plus y equals 5/2, which is kind of annoying because we have the denominator. So I'm going to go a step further and I'm going to take the denominator out. And remember that by doing that, I'm going to multiply this whole thing by 2. So if I take 2 times a negative 1/2, I get negative 1x, right? Plus 2y equals, and then 5/2 times 2 would be 10/2, which gives me an answer of 5. So now it's written in standard form without any denominators, which is what I need it to be. And then if you look at this guy right here, it's already in standard form. And so all we have to do is line up our variables so that they're sitting underneath each other. And when you don't have a number in front of it, that means you have a 1, right? And then this one says minus 2y equals 7. Okay? And now what we're going to do is we're going to use this system up here to help us figure out what's happening. And so we're going to take, let's name this one A, and then we'll name this one A1. And then this one, or let's call this line just A, B, and C, and then we'll call this one A1, B1, and C1. So this is actually A. So I would have, remember, A1 is equal to B1, which is equal to C1, and so we're calling these A to the A power, A to the 1 power. So it's the second line. So we're going to have 1 divided by negative 1, right? Does everybody see that? And then we have negative 2 divided by a positive 2, and then we have a 7 divided by a 5. Now, the rule is that if we have the same answer for each one, then that means that it is the exact same line. So let's check and see. 1 divided by a negative 1 has an answer of negative 1. 2, or a negative 2 divided by a positive 2 gives me a negative 1. So far, so good. 7 divided by 5 is 1 2/5. So right there, that is knocking it out of the situation where they are the same line. So remember what we learned about this, that if you do not have them all the same, then it cannot be infinitely many, because, or what I should say is they are not the same line. Because if all three of them were negative 1s, then that would tell us that it's on the same line. but all three of them are not. This one is different. Really quickly, just because I can, I want to turn this one right here into slope-intercept form. So I would have y equals, and then remember this was a negative x, but I have to divide by a negative 2. So this is really 1/2 x, right? And then remember I divided by a negative 2, so that would give me minus 7/2. So that's what this line looks like. And so what we see is that their slopes are the same. So m on this one is 1/2, and the b on this one is negative 7/2. And then the slope on this one is 1/2, right? And the b on this one is 5/2. So what did we learn in the lesson yesterday? We learned if the slopes are the same, but the intercepts are different. What did we learn that? We learned that the lines are parallel. And if the lines are parallel, then we know that there is no solution. So the answer to this problem right here is that there is no solution. And since there is no solution, we can also recognize that right there because this right here tells us that they are not on the same line. So this right here, same slope, means they're parallel, but intercepts are different, and so they will never touch because they'll always be running side to side next to each other. Okay, so that was that first one. Now let's try the second one. And we're going to try it the exact same way again. First, I'm going to turn them into standard form. So this guy's got to come over. So we have negative 2/3 x, right, plus y equals 4. But we got to get rid of that denominator. So in order to get rid of that denominator, we're going to multiply everything by 3. So that would give us 3 times 2/3 is negative 6/3, which is really negative 2, right? So this would be negative 2x plus 3y equals 12. That's what that one would be, okay? Because you just take 3 times all those things. All right, so then we have this one, which the order is just switched around, so it would actually be 1/2 x plus 2y equals 2. And so what we would like to do with this one is get the denominator out of this one. And by doing that, if we multiply everything by 2, then this one would really be 2 divided by 2 is 1x plus 4y equals 4. So now we're going to compare all of our points. So these are the A's, and so we're going to say this is the A, this is the A1, and so we have 1 divided by 2, negative 2, excuse me. Then we have 4 divided by 3, and then we have 4 divided by 12. Okay, so we have 1 divided by negative 2. The answer is negative 1/2, right? And then 4 divided by 3, the answer is 1 1/3. And 4 divided by 12 is 1/3. And so we can see right here that none of them are the same. None of them are the same. So that's kind of crazy how they're all different. So again, we're going to go back and look at this one and say what happens if we turned this into a y-intercept. I would get y equals negative 1/2 x plus, that would be 2y, 2y equals negative 1/2 x plus 2. Divide everything by 2, so I have y equals negative 1/4 x plus 1. Okay, and so now the slopes are 2/3 and negative 1/4, right? And then our intercepts are 4 and 1. So what did we learn in our previous lesson when our slopes are different? So slope for this one was 2/3, intercept was 4, slope for this one was negative 1/4, intercepts are 1. We learned that when the slopes are different and that the intercepts are different, that you have one solution because they will intersect. Okay, so that's interesting that we found, intersect, I can't spell. Okay, they will intersect at one point. And the reason we know that is because their slopes are different and their intercepts are different. Okay, so found that. All right, let's do the last one. We're running out of room, so I'll try to be more careful with this. Okay, so we have our y-intercept form. So we need to go ahead and turn it into slope-intercept form. So we have negative 3x plus 1y equals a negative 2. And then we have negative 3x plus 1y equals negative 2. Oh, well, now let's use this. Okay, so a1 will be negative 3 divided by negative 3, 1 divided by 1, and negative 2 divided by negative 2. Okay, negative 3 divided by negative 3 is a 1. So 1 divided by 1 is a 1. Negative 2 divided by negative 2 is a 1. Aha! All three of them are the same. So this one, because all three of them are the same, we could pick any number for the x and the y, and you're going to come out with the exact same answer. Okay? So let's try it. What if we said for this one that the x equals 2 and the y equals 3? Okay, so 2 times 3 is negative 6x, right? No, just negative 6, sorry, because x is 2. I apologize. Y equals 3, so it would be negative 6 plus 1 times 3 is 3 equals a negative 2. And so when we come up with that, we would get negative 3 equals a negative 2. Okay, so let's see if the next one does that too. What if I say that the x is 8 and the y is 1? Okay, so let's go. You get 8 times negative 3, that gives you negative 24, plus 1 times 1 is 1, equals a negative 2. And so we're finding that these math sentences are not actually simplifying into the correct amount because we have to make sure that we put those values in. If I put these values into this guy down here, so I would get negative 6, and then I would get plus 3 equals a negative 2. So that's the same. And then what if I put these values into the red one? And let's see what happens. I would get negative 24 plus 1 equals a negative 2. So when you apply this to that one, and you apply this to this one, it is showing you the exact same results. And so that's how we were able to figure out that this would be infinitely many solutions. Okay, and so the reason why they didn't equal each other out is because I didn't actually pick an ordered pair off of the line. This point right here could be somewhere completely off the line. This point right here could be somewhere completely off the line. But what proves that they are the same line is that when you apply them to either one, you come up with the exact same answers when you apply them to both. So that's how we know that that's infinitely many solutions. If I was to graph these two and pick a point that was on either one of them, then you would see that it would be the exact same line. All right, so now let's go to our what did you find out section. No solution means that the lines are, what did we learn about that? The lines are parallel. So no solution means lines are parallel. Okay. One solution, go back up here to one solution, means that they intersect. Okay. Infinitely many solutions means that they are the exact same line. Okay. And so when you graph them, that's where you're going to see that they are the exact same line. So infinitely many solutions means that when you graph the two lines, that they will be the exact same line on the graph. All right, write an example of each type. Then I would say what we have to do for that is, all right, let's do an example of parallel. So remembering the rule for parallel is that your slopes are the same, your y-intercepts are different. So we're going to have y equals 9 halves x plus 2, and we're going to say y equals 9 halves x minus 8. Okay, so those right there would be no solutions because they're parallel. Their slopes are the same, their intercepts are different. Okay, so that's a system of parallel. Okay, so that was helpful for us to remember. Slopes are the same, intercepts are different. Okay, so now let's do a system for one solution. One solution, the rule is the slopes have to be different and the intercepts are different. So y equals 1/3 x plus 5, and y equals 1/5 x minus 3. So our slopes are different and our intercepts are different. So this one is going to be intersecting. Okay, the two lines will intersect at one point. And now the last one that we learned about is that your slopes have to be the same and your y-intercepts have to be the same. And so that means that they are on the exact same line. So let's do y equals 1/2 x plus 2. And then we're going to do y equals 5/10 x plus 4 halves. Okay, and by doing that, what we have to do is we have to check to see if all of those points are the same. So if we would turn these back into standard form, which I would like to do one more time because I want to make sure that everybody understands it. So that means we're going to have a negative 1/2 x plus 1y equals 2. We have to get rid of that denominator, so we're going to multiply everything by 2. So I have negative 1x plus 2y equals 4. That's that one, right? And now we have to do this guy, same way, right? So we are going to go negative 5/10 x plus y equals 4 halves, right? Then we're going to multiply everything by 10 to get rid of the denominator. So we're left with negative 5x, right? Because 10 times 5 is 50. 50 divided by 10 is 5, and it was negative, so negative 5x, right? Plus 10y equals, and then this would be 40 divided by 2 would give me 20, right? And now the last step that we were supposed to do is take a1 divided by a, b1 divided by b, and c1 divided by c. So a1 would be negative 5 divided by negative 1. We'd have 10 divided by 2, and we would have 20 divided by 4. So now let's do that. Negative 5 divided by negative 1 is 5. 10 divided by 2 is 5. Ooh, 20 divided by 4 is 5. So now you found that since all three of these had an answer of 5, we now know that this system right here is infinitely, I can't spell it, infinitely many solutions because of this right here, because you got the three things to equal the same number. Okay, so parallel, slopes are the same, intercepts are different. And that, let's name that too. So remember, when they're parallel, that means that they have no solution. We're trying to get you to remember all of these names, and I know it's kind of crazy. So no solution means parallel. Intersect means one solution, right? Okay. And then infinitely many solutions means that there is many solutions, and the way that you determine it is in standard form, and you come up with this. So infinitely many solutions is they are the same line. Okay, so that's how we determine that one. All right, kiddos, that was a lot of information, but I think you're good. No solution means they're parallel. One solution means they intersect. Infinitely many means that they are the exact same line. Okay, so let's say that one more time. No solution means they're parallel. Slopes are the same. Intercepts are different. One solution means they intersect. Slopes are different. Intercepts are different. Infinitely many solutions means that they are the exact same line. They've just been simplified so that it shows that they are exact same line. All right, so going back up to our goal, today we will use A1 divided by A, B1 divided by B, C1 divided by C to determine the solution, which we did that with all three problems. Okay, what is the only type of solution that we haven't discussed before today left? Infinitely many. So we have no solution, one solution, and infinitely many as our three possible system descriptors. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.